Data modeling has some key concepts. Starting from the entities, now I want to mention these key concepts. So basically there are four key concepts of data modeling: entities, attributes, relationships, and business rules. These are the key concepts that we use in logical and conceptual data models. In physical models, as I mentioned before, entities becomes tables and attributes becomes, most of the time, become columns. But this transformation is important, and we must focus on some details. So in physical objects we have tables and columns and data types. In logical ones we have entities, attributes, relationships, and business rules. Here you can see a relational model for online movie rental system. Assume that this is an old type of movie rental where the movies are stored in DVDs and people go and rent DVDs from these stores. When you take a look at this diagram, first we must understand what is, I mean, not the content, but what, which word means which key concept. For example, the entities are represented by rectangles. So here we see a rectangle, we understand this is an entity. And there are some different notations, but basically the notation we will use has the name of the entity just above the rectangle over here. So we understand that this is customer account entity, and this is customer entity, this is transaction entity. Okay, so the name is over the rectangle in entities. And second, we must understand which are the attributes. Attributes are the words or terms inside the rectangle. So let's say company name is an attribute, address is an attribute, city is an attribute, customer ID, it is also inside the rectangle, so it is also an attribute. So customer ID over here, due date, everything you see inside the rectangle is an attribute of the entity. So acquisition date is an attribute of movie copy. First name is an attribute of employee entity. And the relationships are represented by the lines between the rectangles or between the entities. So these lines over here are the relationships. There are different types of relationships, and we use the signs at the two ends of these lines, and they are very important in data modeling. So after understanding the relationships, next we have primary and foreign key terms. I mentioned them before, but let me repeat one more time. We must have such one or more than one attributes that we can use them to distinguish each instance from the others. Okay, so it is called primary key, and in this notation primary keys are written inside the rectangle in the upper part of the line. So there's always a line in the box, and over the line we mention the primary key. So when you take a look at this, for example, employee table, you can see that employee ID is its primary key. Account number over here is its primary key. Transaction over here is the primary key. And foreign key I mentioned it before and I will repeat one more time. When you use a primary key in another table to join two tables, this is called foreign key. For example, customer ID is a primary key over here, but it is also used over here just to bind these two tables. Then it is called foreign key. And generally, in this notation, foreign keys are represented by FK characters just after the attribute name. So anyone who looks at the table can easily understand that this is a foreign key. So this is the main key concepts of an entity relationship diagram. So, what is an entity? Entity is a person, place, thing, event, or concept about which data is collected. So, there are lots of things, lots of people, lots of places in real world, but we don't want to keep data about all of them. In our system's purposes, if this place, person, thing is important, then we must keep data about it. So we must select the entities which we want to keep data about. If you start keeping data about everything, then your database will be very inefficient. Okay. And here we have, in our figure, we have 4 entities. And in this example, for example, in this customer example, this is an entity, as I mentioned before. But as you can easily understand, a company has lots of customers. The important point here is that we don't keep data or we don't create an entity for each single customer. We define customer as a class, as a group, and define entity for that group. And each element in this group or each single customer is called an instance. The same is true for all of the entities here. For example, for this one, we can have lots of employees. So this group, for this group, we have this attribute. For each single employee, we call them instances. So we have entities, and the examples of these entities are called instances. The key outcome is that when I say customer entity, I don't mean a single customer. I mean a group of customers. Some of the entities are external. For example, when you buy from an e-commerce website, you know that you enter your credit card number and the system contacts with the bank. And in the bank, there's a point of sale machine which checks whether you have enough money or enough credit for this purchase. And sometimes it gives okay, sometimes it gives refusal, so you cannot buy it. So there is an entity outside your website, the e-commerce website. It belongs to the bank, but it affects your system's work. The customer enters the credit card, then your system talks with the bank and get a response. So the entity outside the system are called external entities. It is important that in our database we don't have these external entities because, as I mentioned, they are external. They are not inside our database, but we show them in our flow charts or other diagrams, but we don't have them in our database. Another type of entity is the dependent or independent entity. I just want to inform you the terms. The dependent entity is an instance of an entity can exist without matching instance in at least one other entity. For example, a movie copy cannot exist without the movie itself. So in this type of relationship, let's assume that movie copy is a DVD, and inside this DVD you have the movie. If you don't have the movie, you cannot have a copy of it. So in this example, we call movie copy a dependent variable. But independent or strong entities are not like them. Even if there is no other entities, they can exist. A customer can exist before they rent anything. You don't need to rent something to become a customer. Then it is a strong entity. Notations of entities are very important. Namings are very important. An entity is represented as a rectangle, as I said before. The corners of dependent entity is round generally, and others are not round. And in conceptual model, it is common to add a verbal definition of the entity. In conceptual model, we want an explanation. We don't have the attribute, so we want to see an explanation for the entity. And the namings are very important, both for entities and the attributes, because when you start analyzing something, then you will have lots of entities, lots of attributes, and they will have similar names and you can be confused. So be very careful about naming your entities. You must use unique names. You must avoid technical jargon, because we are designing these databases and diagrams for everyone to understand, not the technical ones only. When naming an entity, you must avoid using attribute names, and be careful about the rules I mentioned in this slide. During your project, I hope, or I guess, you will understand the importance of naming. The entity definition, as I said before, in conceptual data model, we want a definition. Every entity should be accompanied by a clear written definition defined in business terms, so that all the business related people can easily understand. For example, there can be some problems when the definitions are not correct, or you don't spend time in thinking about these definitions. For example, here we have two definitions: customer, an individual or household that rents movies, and customer account, the record of credit entries for movies rented, purchased, or returned by a customer. So in the first look, everything seems okay. We have an entity name, then we have the definition. That's great. But please think for a little. Please stop the video here if possible and think about it for a moment. There are some problems. Now I will wait for a few seconds for you to see the contradictions in these definitions. So I hope you have some ideas about these contradictions. One of the contradictions is in customer definition. We have a definition like this, and we say that the people who rent the movies are our customers. But here in customer account, we have a term like purchase. Are we selling these movies or are we only renting them? We must be careful about this. We must be very clear about it. If we are also selling them, then it must take place in this definition also, because they are not consistent. And another contradiction or gray area is, okay, when we think about customer, okay, we understand that it's an individual, but what is an household? How we define household? What is it? How can I define a person is an household or not? These are not clear. And critical thinking is very important here, and as industrial engineers, you must be very careful about this. It is not like, the data modeling is not always like translating what people say into diagrams. You must find the problematic areas, you must find the problems, you must find the contradictions between definitions and ask questions immediately or later. You must go to the person who defined it like this and ask, what is household? Can you explain me what is household? Or can you explain me, are we renting them or are we selling them? You must ask these critical questions to have a good system and to have an efficient database. So these are the problems about these two definitions. So avoid technical jargon in definitions, distinguish the entity from all others, and distinguish one occurrence from another, so one instance from others. So we must have a definition and obey these rules. And we have entities in the conceptual data models first, and there are alternative conceptual modeling diagrams. One of them is like this. As you can see, we have the entity names and the relationships only in this notation. This is also a conceptual data model notation. It holds attribute names inside the rectangles. It looks like a logical one, but indeed it's a conceptual one. The one I want to have in your projects is this notation, similar to this one, but here the name of the attributes, the name of the entities are written outside the rectangle, and the definitions are written inside the rectangle, so the reader can easily understand the data model. So as I mentioned before, this is the notation that I want to see from you in your conceptual models.